Okay guys, today we're going to look at a review of logarithms. So let's just start with question 5. So for question 5, we're going to rewrite this in exponential form. So that would give us 8 to the y equals 2. Okay, so the way that you learned in Algebra 2 to solve this would be to rewrite both sides so that they have the same base. So 8 is really 2 to the third. So we know that for the two sides to be equal, the exponents must be equal. So we get that y must equal 1/3. To raise something to the 1/3 really just means to take the third root. It means what number multiplies 3 times to give you 8. Okay, let's look down to 7. So for 7, we rewrite this as 64 to the 2/3 equals y. Again, the denominator of the exponent tells us which root to take. So the third root of 64 is 4. 4 multiplies 3 times to get up to 64. And then 4 squared is 16. Okay, for number 8, we have 27 to the negative 2/3 equals y. The negative sign in the exponent just means to take the reciprocal. So we can figure out our answer regularly and then just flip it. Okay, so the cube root of 27 is 3. 3 squared is 9. And then we take the reciprocal, which is 1/9. All right, so now let's look down at some examples where we're adding. So if we look at 17, for 17, we can figure out what each individual term equals and then add them. So the first log evaluates to 2. The second log will evaluate to 3. So when we add them, we get 5. If you notice, when you look at 18, we have log base 2 of 32 equals y. So that must mean that y equals 5. We notice that we have the same thing on both sides. And you may remember back to Algebra 2 that when you add two logs with the same base, you can put them together in one and multiply. So let's look at that a little more, and let's look at why that is. So what we want to do is prove that when you add two logs with the same base, it's really equivalent to putting them into one and multiplying. So we're going to start by saying we'll let x equal log base b of m, and y equals log base b of n. Now, that means that if we multiply, now we can rewrite this in exponential form. So that means that b to the x equals m, and b to the y equals n. So now if we multiply, we know that m times n is the same thing as b to the x times b to the y. So we can now rewrite the right-hand side as b to the x plus y. I'm going to take the log of both sides so that I can get the variable out of the exponent. So what I then have is log base b of m times n is really the same as x plus y times log base b of b. Well, log base b of b is just 1, so we can write this next line. And we know from the beginning that x is really the same as log base b of m, and y is the same as log base b of n. So we've proven what we set out to prove.